Just other teachers. No one in particular. No one in particular. Oh, I heard Tyler Vandermark.
We don't know how we fed one person per person.
That's what.
I was like, I don't know. I'll have a person.
I used to have a subscription to the magazine, kids. Like I'm not lying. When I was in high school, like my entire room was wrestling posters in my wall. Like I'm not like it's not a lie. Like that's not an exaggeration. Like I would get the magazines and I would cut pictures out and put them on my wall. And but I thought that, they're cute, but then also I just liked it. Like I liked watching it. I liked getting in the story, and I rooted for them, and I enjoyed watching it. I paid to go to many pay-per-view events. I went and I made a poster to hold up. Like I was hardcore wrestling fan, so I.
We were going to like school.
We're never gonna do this thing. All right, we have to do math. As much as you know wrestling. We can't do more wrestling, but I don't watch it anymore. I really don't. There's a girl that I used to work with at Kroger that is a nurse at IU Hospital in Indianapolis, and she loves wrestling. She's like 27, and every Thursday night she's like, so excited for SmackDown. That's a Thursday night wrestling show. And then on Monday she's like, can't wait to watch Raw tonight. That's the Monday night wrestling show. Every week, like she's obsessed with it. So, and she's 27, so, and she's cute and normal and like, like girls like wrestling too.
Do you like watching real wrestling?
No, it's boring. When I was in high school, I dated a boy who wrestled, and I went to one wrestling match, and I was like, this is the worst thing I've ever seen in my whole life. No offense to anyone that wrestles, but it was not entertaining at all. Nothing like the WWF or WWE. It used to be called WWE.
Have you ever watched South Park before? Yeah, like I'm thinking of this one episode. It's perfect. I gotta find it for you. I'll show you.
I don't think I want to watch South Park.
You'd love this specific episode.
So in 6.3, we talked about parametric equations, and now we're going to switch to polar coordinates. And so here's the confusing part. Two totally different ways of graphing functions that aren't functions. So you kind of just got to forget about parametric for a minute, and then let's just go to this, and then Friday we'll kind of put it all together and try to figure out what's right. The cool part today, maybe not as cool as wrestling, but almost, is that instead of graphing on the normal xy plane, that's called the rectangular coordinate system. Probably you never knew that it was called rectangular coordinate system. You just called it the normal coordinate system. But when we graph on the x and y axis, it's rectangular. When we graph on the polar coordinate system, instead of graphing x and y, we graph r and theta. And this, you don't have to draw this circle. I'm going to give you one in a minute. This is what this is what a polar coordinate system looks like. And so it has these cool circles, yes, and it has these awesome lines going through it. It's cool. So let's say I had a point right here that was P. So maybe on your paper, you should draw this angle, and you should label this point P. You don't have to draw the circles around it, because I'll give you one in a second. It's kind of cool. How do you know what r and theta are? Well, theta is just the angle. If you measured from 0 up to here, on mine, which I know you don't have on your paper, but maybe you could draw like this line and this line through yours if you wanted. What's that angle right there? 45, or I'm going to write it in terms of radians. That would be pi force. So that would be my theta. And what do you think r stands for? The radius. You see how there's these circles on this graph? It just means what is the radius if you drew the circle in from this point. So you can just count the circles. You see how this would be a radius of 1, and this circle would be a radius of 2. So you just count 1, 2, 3, 4, 5, 6. This would be a radius of 6, which I know is hard to see on your paper because you don't have those circles to go around, but I'm going to give you one in just a second. Okay? And so instead of x's and y's, we have r's and theta. So that's the radius of the circle if you drew it in, and that would be the angle that it is located at. Yeah, that's a polar coordinate graph. So I have polar coordinates for you, like these little graphs. We're going to use one in our notes. can graph more than one point on one. They were complaining in second hour because there's so many lines on it because it goes by increments of 15 degrees, but I think you'll be okay. Or when you get to your homework, if you really don't like it and you want one that's like mine, I can give you this big giant one. One of this big giant. I think it's the whole page. But I'll give you this one for your notes. And then my advice is on your homework, you use this little one, like cut it out and like tape it to your notes or staple it to your homework so that it stays with it. Because there's certain problems on your homework that you're just graphing these dots that you need on these graphs for. But this is for your notes. You can figure out the notes with it. I'll give you one for your homework in a minute. And you can decide if you want the little one or the big one. I think I may count it too many there, but okay. I don't like that the degrees are on here because I feel like you should be able to know the angles. I'll tell you on a test. It'll be more like the blank one. I'll show you in a second. The blank one that you have to be able to tell me the angles. But the good news is I want you to use radians. So, so the blank one. Why do we use polar coordinates? Sometimes graphing things such as this, which we are going to graph next week, really hard to do with x's and y's because think how many different equations you'd have to write to graph that equation. With polar coordinates, that's one equation. Like it's a lot simpler to get that kind of graph. Great for trig stuff, which is why it's so great for us to do it this semester with all the other trig that we do. And again, up until this point, for the most part, you've only dealt with functions. These allow us to use stuff, deal with stuff that are not functions. And there is a lot of connection there with vectors. We're not doing vectors this semester, but if you take more math or you take physics, you'll do a lot more with vectors. Yes, you could. And actually what we're going to do today, besides graphing, is we're going to go back and forth from, not graphing, but we're going to take rectangular coordinates, x's and y's, and change them to polar, and polar coordinates, and change them to rectangular. Sometimes it's just easier to graph on a polar coordinate. But yeah, you can graph lines on these if you want. It's just kind of silly because it's easy to graph a line. You can graph circles on these, you can graph parabolas on these, but you can also graph crazy graphs on these. But yes, it's just another way to graph. One that most people don't know about. This is the kind of polar graph that I'm going to give you on a test where it's not labeled because I want you to be able to do the angles. I picked really nice angles here for the ones that we're going to graph, but just know it could be any angle. It could be like pi sevenths. Pi sevenths is not on a unit circle. It's not on the circle I gave you, but you could figure out roughly where pi sevenths is. So let's do a couple of these, and then we'll talk about what these negatives mean and how that changes everything. And so we're just going to plot these, and we're going to do all four on the same graph. And there's some on your homework. I think you have to do 7 through 13, and they're all just plotting points, and you can just put them all on the same graph. You just want to make sure you label. So if you want to like write this right on that piece of paper I gave you, or if you want to just write it on your paper and then you can tape that little polar coordinate on there, I'm okay with that too. I need to get a polar coordinate stamp so that you can just go through and stamp it on, but not that cool yet. Almost. So starting with the first one, that one's just like the one that we did to begin with. 4 pi 6, what does that mean? That means a radius of 4, so that means the fourth circle, and go to pi 6. Notice on yours it goes by increments of 15 degrees, so I think that would be the second angle on yours, right? But mine just is broken up into 3 sections in quadrant 1. So this is pi 6, pi thirds, pi halves. So the fourth one at pi 6 would be 1, 2, 3, 4. I'm just going to put a dot there, label the point, and since we're going to do more than one on a graph, just put a 1 next to it so you know, hey, number 1 is right there. And I have a question on where I'm getting that from. Make sure you count right. It's really annoying when you get it wrong because you count wrong, and you're like, oh, I put on 3 and I should have put on 4. It makes you mad. Then you yell at me for taking your point away. Everybody with me on that one? How about number 2 says 2 negative 3 pi halves? What do we do with negative angles, or how do we graph negative angles? Yeah, there's two ways to do it. One way is you could just negative means instead of counting positive, we count backwards. So you could say on the second circle, if I go backwards, this would be negative pi halves, negative pi, negative 3 pi halves would be up here. What can you do to a negative angle to make it positive always? Add 2 pi to it. So if you wanted to add 2 pi to that, these are the exact same point. 2 negative 3 pi halves is the same as 2 pi halves because it's the same angle on the same circle. Does that make sense? So don't be thrown off by negative angles. So same idea with number 3 there. I want the third circle, but I want negative 5 pi. You could just go around, find where negative 5 pi is, or you could just keep adding 2 pi until you get a positive one. Either way, where do you end up? What angle? At pi, because if you add 6 pi to that, or if you just went backwards here and you said 1 pi, 2 pi, 3 pi, 4 pi, 5 pi. But you gotta count the third one. 1, 2, 3. Number 3. It's really important that you number them because if I was grading this, how would I know which one's which if you don't put the number next to it? You can put the point next to it if you want, but to me it's easier just to number it. What about number 4? Number 4 is a little crazier, right? Number 4 has a negative r value. How do you do negative r on here? There's a couple ways to do it. For me, I always just use in your book, they tell you how you can rewrite these, that if you have r theta, that's the same as if you change the sign of r and you added or subtracted pi to your angle. So if you want to change r, you have to add or subtract pi. And then I'll show you visually in a minute how to do that, and then you might be able to see it better and maybe like that way more than the formula way. So if I wanted to do negative 1 pi thirds, I know that's the same as if I change r, I have to add pi to this, and if I add pi to pi thirds, that's going to be 4 pi thirds. Or you might say, how do you know whether you should add pi or subtract pi? You're going to end up at the same spot no matter which one you do, because if I'm at pi thirds, that would be right here, right? And if I at pi thirds and I add pi, do you agree I'm going to go this way? If I'm at pi thirds and I subtract pi, do you agree you're going to end up at the same point? So some people just like to go to the, like they don't actually write it out. They just go to the positive one, like they say negative 1 pi thirds, and then they say, okay, now I'm going to add pi, and I'm just going to flip it over, right? Like you can just see that you're flipping it. Philip pointed out today, this is what he said, which I've never thought this way, but you know, Philip likes to make me use my brain a lot. He said if you just look at the pi thirds line, you agree that that would be like the pi thirds. He said he just looks at the pi thirds and he just went down 1 instead of up 1, which I find weird, but it works. Like he said, this would be, for him, this would be pi thirds 1, so this would be pi thirds negative 1. And I said, that works. I never thought of it that way. And as long as you get your dot down here, I don't care how you get it there. But that's why it doesn't matter if you add or subtract pi, because you end up in the same spot. No, yes, maybe. So just be aware of that. This is the one that gets people, is the negative. Deborah. If you had an r value of 0, no matter what theta is, do you agree you would just be right there at the center? So you could, like if you had 0 any angle, no matter what it was, it would just be like at the origin, or they call that the pole. I never call it the pole, I call it the origin. But it would be a radius of 0, so it could be any angle. I don't think that they would give you one, but it would just be that point. Okay? So part of your homework is just this today. That's not so bad, right? The other part of your homework is converting, showing you what Deborah said earlier, that really you could graph on the xy plane the same as the polar coordinates, just depending on which one you want to do. So we got to go back and remember some trig stuff to do that. So let's write a few things out for a minute. Do any of you watch wrestling? There's still a lot of people that watch wrestling, you know. Royal Rumble.
What's up?
Royal Rumble.
Yeah.
Oh, Royal Rumble's the best
I
one.
was always the first one in. I was like, oh my gosh, because then I get eliminated like 10 people down.
Royal Rumble, 30 people in the ring at the same time. Last man standing gets a free shot at the title at WrestleMania.
Well, it's not. It was like the first person goes in, and then more people slowly go in.
Right, yeah, yeah.
So, and I was,
Oh yeah, that's Royal Rumble. Like every 2 minutes, someone comes in.
yeah.
It's been a while.
So I was every time.
And I just see this is why I know people still watch it because on Facebook, maybe I'm just friends with wrestling people, but in March is always WrestleMania, and I don't watch it anymore. But I saw on Facebook that the Undertaker, like he had an undefeated streak at WrestleMania for his whole career, and then he just lost. He just lost at WrestleMania for the first time ever, and so his undefeated streak is over. And people were appalled on Facebook that the Undertaker lost. There's some weird stuff on wrestling, but Parker wants me to show him wrestling moves all the time, but sometimes I forget that he's so little. And the Undertaker's move is the choke slam, so he picks you up by your neck and he slams you on the ground. And so I might have done that to Parker. Slam him on the ground a little too hard, because I thought he would put his hands out, but instead he just laid there. And so I was like, choke slam, slam. Oh, that was hard. And I was like, I'm so sorry. I felt really bad. If it makes it any better. My little brother and I, like, he always wanted to wrestle. Like this, like he's younger than me, like 8 years younger than me. So he always wanted to wrestle, and we would put a blanket down that was a wrestling ring, and we would do all the moves. Like that was like how he wanted to play all the time. So we would do choke slam, and we would do the figure four, and we would do all the wrestling moves. But it was just pretend. Like I didn't really hurt him because I wasn't really fighting as hard as I could. And the same thing with Parker, only I kind of forgot that Parker didn't know like to put his hands out, because I would choke slam my brother too, but I would like choke slam, and I would go down, and then he would put his hand out, so he doesn't really hurt. It was just pretend, but Parker didn't know, so slam on the ground, and then like it was bad. I felt terrible. I was very, very mad. And so then the next day he did it. He said, "Let's do more wrestling moves," and he said, "But let's do ones that don't hurt me." You know, it happens.
We should discuss this with the people.
I don't want to tell him all these things. I'm going to tell them I chose them. So how do we convert? This goes back to right triangle trig, because any angle that you draw, this is theta, the height is y, the base here is x, and this is r, right? So if we wanted to give the ratio for sine, it's been quite a while since we did this, but remember that sine is just opposite over hypotenuse, so we could say that sine equals y over r, and we could say that cosine is adjacent over hypotenuse, which is x over r. Yes, so I just like to show you this to show you where these equations come from. It's not something new, it's just making you remember this. So if I want to solve for x, you agree that you would just multiply r over here, and you would get x equals r cosine theta, multiply r over y equals r sine of theta. Yes? That's going to be helpful in a minute. You might need to use tangent every now and again. The ratio for tangent, I was telling you in the second hour, I don't know why I wrote this twice, because I don't have a cool way to solve it. Because the tangent is just y over x. If you solve for x, you solve tangent, so I just wrote it again as y over x. It's not very good. And then just remember that this is a right triangle, so if you want to relate r to x and y, it's just Pythagorean theorem. I like to say that r equals the square root of x squared plus y squared. And using all this information that we've learned since chapter 4, right? Chapter 4? We can convert from polar to rectangular and rectangular to polar by just using these equations. So it's just plugging stuff in and evaluating it. And hoping for the best. So I just have a few more examples. Think how early would have been done if we didn't talk about my wrestling obsession. I have to say, I still keep those wrestling shirts that I wear sometimes because I just can't throw them away.
You should wear it more to school.
We're not allowed to. You have to wear, you can't wear t-shirts on Fridays. I'm not going to come to a sporting event in a wrestling shirt. It's embarrassing enough on Throwback Thursday when I drop my kid off at daycare and I have Brett the Hitman Hart on my shirt. So
How's that embarrassing? That's just
it's embarrassing. Like, I don't really watch it anymore, so it's kind of embarrassing. So really important that you understand the directions here, because most of the time you don't think rectangular means x and y, but convert to rectangular means they're giving you the polar coordinates. So it's like they're giving you r and theta, and they want you to change it to x and y. On a test, I can't tell you that. Like, you got to know what the directions mean. Sometimes you're going to see in a minute that maybe you can just use what you know to not actually do a lot of work, but we can always use these equations to get it to work out. So on this, remember that this is r and this is theta. And we just wrote out that y equals r times sine of theta, and x equals r times cosine of theta. So to convert from polar to x and y is really not that bad, because can I just plug in r and theta and then evaluate that? Yeah, you just got to know those equations, which you will have to know for the test. I'm not giving them to you. So I could say I know that y equals 3 times sine of pi halves. And what is the sine of pi halves? 1. So 3 times 1 is 3. And I know that x equals r, so 3 times the cosine of pi halves. Cosine of pi halves is 0, which means if this was your polar coordinates, then your rectangular coordinates would be xy, remember, 0, 3. And this is one that you could argue I don't need to show any work on, because if you think about a radius of 3 and an angle of pi halves, does it make sense that it's up 3 on the y-axis? See what I'm saying on that? Which means if you just thought about the angle on that, you could be like, oh, I know, that's 0 up 3. And you could actually get it without doing it. Okay? This always works, and I usually work it out because I don't even think about the shortcut, but I'm okay if you recognize that you don't have to do all that work. But for something like number 6, there's no shortcut. You have to work out what is the x and y coordinate that goes with a radius of -2.5 and an angle of 1.1. In second hour, someone said, how do you know if that's in degrees and radians? And what's the answer to that question? There is no degree sign, which means it's in radians. 1.1 radians is just not a nice angle that we normally think of, but we can still find the xy point that goes with it. It's just not going to be a very nice point doing the exact same way. So I can say, I don't know why I would always do y first, but I do. I could say y is -2.5 times the sine of 1.1. Make sure you're in radian mode on your calculator, and you just type that on your calculator. Should have my paper out, but instead I'll just type it on the calculator. Radian mode, -2.5 sine 1.1, -2.23 if I'm going 2 decimal places. Did you get that? Anybody's even typing it? Then x is -2.5 times the cosine of 1.1, which again, this is not hard to do. It's just remembering the formula and then typing it in correctly. And I think that you would get a -1.13, which means the ordered pair that goes with -2.5, 1.1 is -1.13, -2.23. I will tell you that I'm okay if you use your calculator for ones that, like, you shouldn't need your calculator for pi halves, but if you use your calculator, it's going to give you the same answer. But just be aware that, like, if you know, like if it was like square root of 3 over 2, I expect that answer as a square root, not as a decimal. So just be careful relying on your calculator too much. Does that make sense what I'm saying? Like, just I think if you should be able to use your unit circle, you can give me an exact answer. Some of you have calculators that give you radicals, so that works out well. But if you don't give me decimals when it should be an exact answer. Questions on converting from r and theta to x and y? Just straightforward. The other way, a little bit more thinking involved. If they give you x and y, we want you to be able to go to r and theta. These are my last 2 examples. Which means even after all of our talk, you still should have some time to do your homework maybe. So again, convert to polar, and I think the directions in your homework actually say like convert from rectangular to polar. But to polar means they're giving you the x and the y, you're finding r and theta. Still using the same equations, you just had a little bit more work to do. So on this one, they give you the square root of 3 and negative 1. So this is like your x and this is like your y. We need to find r and we need to find theta. Do you know which one we could find right now? Yeah, you have to start with r because you don't have enough information to find theta right now. So when they give you this, step 1 is you're going to want to find r. Because to find r, we could just do Pythagorean theorem, right? And actually, I always just do the solve part. R is the square root of x squared plus y squared. So what's that going to be? 3 plus 1, square root of 4, r is 2. Then we need to find theta. We have two equations that we could use to find theta. We can use x equals r cosine theta or x equals r sine of theta. Theta is going to be the same no matter which one you do. It's just solving the equation. So it doesn't matter. I'll use x on this one. X equals r cosine of theta. And so that would be what? The square root of 3, I'm going to go ahead and divide r over. And I'm going to get that the square root of 3 over 2 equals cosine of theta. You with me on that? Now here's the part that you got to think. First of all, the difference between these problems and the ones we just did is you got to do a little bit more work. But also you got to think here, because do you agree that there are two different angles where cosine equals the square root of 3 over 2? How do you know which one to pick? It goes back to here. Where would this be graphed? What quadrant would the square root of 3 as x and negative 1 as y be? If I graphed square root of 3 here, and then I went down negative 1, this would be in quadrant 4, yes? You're drawing that angle in. So you don't have to draw the picture, but you have to be aware that I want the quadrant 4 answer. So where in quadrant 4 does cosine equal the square root of 3 over 2? 7 by 6 would be over here, right? 11 by 6. Right, one click away from the x-axis. Oh, and negative pi 6 is okay as well. Because like in the other equations, like they would give you the interval from like 0 to 2 pi. I always give the positive one, but negative pi 6 would be a correct answer. And so we could say that this is 2, 11 pi 6. Or, Savannah, you could say 2, negative pi 6. That's exactly the same. Or in second hour, they like to be a little crazy sometimes. They said, well, what if you made the 2 negative? Then that would make this negative square root of 3 over 2. And then that would be like over here and be 7 pi 6. Who would think of such things? Not me. No, 5 pi 6. Right? 5 pi 6. Whatever. I would never think of that, but I would count it right if you did that. Why make it more complicated than it needs to be is what I say. But both of those answers are good. So I did two examples here. One where you should be able to use the unit circle. This is what I mean by if you did, let's say you didn't know what this was and you want to do your calculator and you hit inverse cosine. In radian mode, your calculator is going to give you the decimal for 11 pi 6, and that's where I have an issue because I want you to give me 11 pi 6 as 11 pi 6. So if you're going to use your calculator, because I'm not going to give you a test with some calculator and some not calculator, make sure, like I would say, keep your calculator in degree mode and then change the degree to radians, is what I would say. And we'll talk about that tomorrow as we talk about your answers. But just don't give me decimal answers for your angle if it's an angle from your unit circle, is what I say. But what about this one? If you try to do this and you solve for r, I think you end up with the square root of 169, which works out to be 13. And again, it doesn't matter whether you do sine or cosine here. in the unit circle, because 5 and 12 is not in our unit circle. I did cosine on that one, so I'll do sine on this one. That would be our sine of theta, so I would get 12 over 13 equals sine of theta. With me on that? If I want to solve for theta, and that's not in my unit circle, what do I do on my calculator? Yeah, I'm going to do inverse sine of 12 over 13. Radian mode, I want the answer in radians, but just be careful on the ones that should be like 11 pi 6. And this would be where you still got to think about what quadrant you're in, because remember that your calculator only gives you certain answers, and I'll tell you that it gives you quadrant 1 if the answer's in quadrant 1, but if it's in 1 and 4, it's only going to give you 1. So 5 and 12, where would that be graphed? Quadrant 1, so that means we're good to go. But if it was somewhere else, you got to think about that. Like, do I need to add pi, or I need to do something else? It's like a review of all the trig that we've done. How exciting is that? I got 1.18. You should get the exact same answer if you did inverse cosine of x over r. Which means my answer here would be r is 13, theta is 1.18. I can guarantee on your test, you're going to see questions that are both nice angles from our unit circle, and you're definitely going to have one that's not from the unit circle that makes you use your calculator to do that. And that's what you're doing on your homework tonight. Graphing, converting both directions. So make sure you read the directions on what to do on that. So 641, you are going to do 1 through 4, and then 7 through 13 are all graphing points, and I'm going to give you one graph that you can graph those on, and then the rest are some converting, maybe some little problems at the end. So I'm going to come around, and if you want another little graph, I'll give it to you. If you'd rather have a big graph, there's a giant piece of paper. I can give you that as well, that you can have. Okay, so you're just going to tell me what you want. In second hour, they're concerned that they might not have enough circles on the big graph. So if you look at 7 through 13, if there's lots of numbers that are bigger than a radius of 4, you could like just sketch in a little circle in there, or you can just kind of do your paper. I have big ones that also have that many. I know that. Yeah, that's nice. I have one like this big. I also have ones like this big. Yes.
I have a little one.
If you pick a big one, you could just do the rest of it. It did not work out so well. You want me to wing it? Let's see. You want me to do it? Okay, well, I think of it.
That's not the letter.
also just, you're still welcome to come in if you have questions in the morning or if you need to retake a test. I'm having calculus morning review sessions pretty much every morning until the exam. So if you come in and we're doing calculus, don't be intimidated or think that you can't come in. Just be aware that we're in doing calculus problems on the board every day at 7:40. So hardcore in calculus.
How many people are in calculus?
7.